In this video, we're going to estimate the delta H for the combustion of propane. So, in addition to all the ways that we've previously calculated enthalpy, we can use Lewis structures and bond enthalpies to estimate the overall enthalpy of a particular reaction. So, in this case, we have C3H8, which we can draw the Lewis structure like this. So we have a carbon in a chain with 8 hydrogens around it, plus 5 of these oxygen-oxygen double bonds. These guys are going to react together to form 3 CO2s, which we can draw like this, plus 4 waters. So here's our Lewis structures of what would form when we have our reactants and our products, and we can estimate the delta H of a reaction by saying the sum of the bonds broken minus the sum of the bonds formed. And remember that when a bond forms, it's going to stabilize the overall energy of our system. And that's why we have this negative sign right here. Because when that bond's formed, it's forming that energy. And it's becoming more stable. So our delta H of the reaction is going to be the sum of the bonds broken. So if we look at our reactants, which I've drawn up here, there's going to be 1, 2, 3, 4, 5, 6, 7, 8 carbon-hydrogen bonds that are broken, plus 1, 2 carbon-carbon bonds that need to be broken, plus 5 times an oxygen-oxygen double bond that's going to be broken. Then if we look at the bonds that are formed, we can see that there's going to be 3 times one of these carbon-oxygen double bonds plus another 3 over here on this side plus 4 times 2 times the oxygen hydrogen bonds in the water. So it's going to be 8 times the oxygen hydrogen bond here for each of these water molecules. So now we need to take and solve for our delta H of a reaction, and each of those bonds we can approximate to be a mole. So we can say that 8 moles times the carbon-hydrogen bond enthalpy, which will be 413 kilojoules per mole, plus 2 moles times the carbon-carbon bond, which would be 348 kilojoules per mole, plus 5 moles times the oxygen-oxygen bond enthalpy, which will be 495 kilojoules per mole. This is going to be minus the entire term of, here we have 3 plus 3, or 6 moles times 1072 kilojoules per mole, plus 8 times the oxygen-hydrogen bond enthalpy, which will be 463 kilojoules per mole. So if we do the math, we can get the delta H of the reaction by adding up all the terms here, and we're going to get negative 3661 kilojoules for our total delta H of this particular reaction. So when we set these up and we look at delta H using bond enthalpy data, we must draw out the Lewis structures. And from that Lewis structure, we can then take a table with our standard bond enthalpies and then take the delta H of the reaction to be the sum of the bonds broken, because it takes energy to break bonds, so that's going to be positive, minus the sum of the bonds formed. When a bond forms, they become more stable, they lower in energy. That's why that negative sign's there. Then we add up all the components and do the algebra and figure out what the delta H of that particular reaction will be.